welcome back to another math lesson video. In this video, we'll be going over Math 8, Lesson 3, okay, which has to do with Chapter 10, Section 5, okay, which is about writing scientific notation. Just for reference, if you wanted to follow along in the book to see the examples and to see what the section's even talking about, this section starts on page 408. Okay. Now, what we did in last section was, if you recall, it was about reading scientific notation. Okay. So we're actually going to be doing the opposite in this section, which is actually writing numbers in scientific notation and going from standard form to scientific notation. Okay. Now, this section is actually pretty short in terms of what content is there. The majority of this is going to be examples. Okay, so hopefully this will be a shorter video than some of the other ones. But you do need to pay attention and look and see how these examples are done and how I think through and how I talk through how to do these examples. Okay, so first things first, let's take a few notes here on what we actually need to do to write numbers in scientific notation. And then, like I said, we'll jump into the examples so we can see how we can actually use this. Okay, so first things first, how do we write a number in scientific notation? Well, there's technically three steps here. Now, these steps aren't going to follow along exactly with how they do it in the book. Once again, I want to try to explain it in a more simple way that you might be able to understand over how they describe it in the book, which once again, the way they describe it in the book is perfectly fine, okay? But like I said, I want to make it a little easier for people to understand in how and to do these types of questions, okay? So the first thing we got to look at, so step 1, is if we have a number in standard form, okay, that means we have just a number. If you remember what standard form means from the last section, we just have some number, okay? Now, the first step is with that number, we need to move the decimal point to be after the first non-zero number. Now, with me using the term non-zero number and all this, once again, in words, this can be a little bit confusing, but if you look at the examples we do, you'll know what I mean by first non-zero number. So I'm going to underline non-zero number because it is kind of important, but if you don't know what I'm talking about, what I mean by non-zero number, like I said, let's look at the examples and we'll figure it out there. Step 2. Okay. In this case, after you've moved the decimal to the first non-zero number, you count how many spaces you moved the decimal point. So much like we did the last time, we want to count how many spaces that we move it, except in the last case, we know how many spaces we need to move the decimal point. We're not told that here, okay? How many spaces we need to move the decimal point is, I guess, given by what we have to do in step 1. And like I said, if that's confusing you, what I mean by non-zero number, we'll go over that with a few examples here. And then lastly, step 3, okay, is write the exponent on the 10 as either a positive or negative. And I'm going to put on here whichever makes sense. And once again, if you're not sure which one makes sense for you to use, whether it's positive or negative, that's what we're going to talk about in the examples. Okay. So just for a couple different examples here. Let's say we have the number 8,600. And we want to write this as a number in scientific notation. Well, in the number 8,600, the decimal point is right here after the ones place. So if we wanted to, we could rewrite this. We could write this number as 8,600.0. So we can see where the decimal place is. Okay. And then what we want to do is we want to move the decimal place to where it's directly behind the first non-zero number. Now, if you look at this number, 8,600, what's the first number that you see that's not a zero? Well, it's the 8, okay? So what we want to do is we want to move this decimal place over 1, 2, 3 spaces, okay? So in this case, the number 88 or 8,600 can be written as 8.6. So 8.6. We can leave off the rest of these zeros, but if you wanted to include 0, 0, 0 there, that's fine. But this is 8.6 times 10. And then now we have to make a decision, and that's what step 3 is about. We need to write the exponent as either a positive 3 or a negative 3. And this is where kind of some common sense has to be. You have to have some common sense about this. What are we doing when we want to take this number 8.6 and we want to make it into 8,600? Well, that means we would want to make that number bigger. So that means we would want a positive exponent of 3 here. Okay? And like I said, we'll see this again when we look at example 1. This is just a little starting example here to show everybody, which I guess I need to make a note for the people that'll be just looking at the notes here. This is the number 8,600. Okay. But when we're finished, that means we've got the number 8.6 times 10 to the third. Okay. Now, if you wanted to double check yourself, you could go backwards. So you could start with the number 8.6, move the decimal place 3 places to the right, and make sure you go back to the 8,600. Okay. That's one way you can double check yourself. Now, let's look at one with a negative exponent. So let's do 0.0024. Okay, well, once again, we'll write the number here, 0.0024. And the decimal is right here, behind the first zero. Okay, now, since the decimal is right there, what's the first step? We need to move the decimal point to be after the first non-zero number. Well, this number is a 0. This number is a 0. This number is a 0. So the first non-zero number we have is this 2. Okay? So what we need to do is we need to go to the decimal place right here. So put our pencil down at the decimal place, and we count over how many spaces we need to go to put the decimal after the 2. So we go 1, 2, 3. Okay, and that's where the decimal is going to go. Okay, the decimal point is going to go between the 2 and the 4. So now, once again, we get down to where we need to write this. That means we're going to have the number 2.4 times 10. And now in this case, we need to make sure we're making sense with this. We moved it 3 spaces to the right, okay? But once again, we have to think about this logically. The number 2.4, okay? If we're writing this number as a number in scientific notation, we want to make this 2.4 smaller into 0.0024, okay? So that means we would need to use a negative exponent, okay? So once again, it depends on what you're starting with. If you're starting off with a smaller number than 2.4, you'll need a negative exponent. If you're starting with a bigger number than 8.6, you need to use a positive exponent. So think about it as it's going backwards, okay? If we wanted to make this 8.6 bigger, we'd have to have a positive exponent. If we wanted to make this 2.4 smaller, okay, like we want up here, we're going to have to use a negative exponent, okay? So once again, make sure you use the correct sign on your exponents. Okay. And like I said, we'll see this again in example 1, but I just wanted to give you a couple quick examples here to show you what we're technically doing here and how we need to go about the steps. First step is move the decimal place. So that's actually physically move the decimal place to where it's after the first non-zero number. Count how many spaces you moved it. So in this case, 1, 2, 3. Okay. And then to tell you whether you need a positive 3 or a negative 3, that's going to depend on what number you started with and what number you end up with. So in this case, we started with 8,600. We ended up with 8.6. So we would need to make this 8.6 bigger to make it the 8,600. So we need a positive exponent. Same difference over here. We started with 0.0024, okay, but we ended up with 2.4. So in this case, we would want to make this 2.4 smaller, so we would need a negative exponent. Okay, you got to kind of think backwards with these when you're working these out. So with that being said, let's go ahead and jump into the examples. And we've got 3 different examples here, 3 different types of questions you could be asked there. So do pay attention to all 3. Let's go ahead and look at example 1. Once again, this is directly from the book. And this has to do with writing large numbers in scientific notation. Okay, so in this case, it is technically kind of a word problem, all right? So they're going to give you some extra information here, but what you really need to focus on is the number that they bring up, okay? Because all we're going to be doing is looking at the number that they mention here, and we're going to ask to write this number in scientific notation. So example 1, it says a social media company raised, and they give you a big number here. So this is $3,400,000,000. So $3,400,000,000, and the rest are zeros, so that's $3,400,000,000 when it first sold its stock to the public. Okay. Once again, a lot of extra information there. If you don't know what it means to sell stock to the public, or you don't really know what it means, social media companies, probably something like Facebook, Instagram, I guess technically even YouTube, it could be considered a social media company. But once again, we don't need to really focus on this what this number is in relation to here. First sold its stock to the public. That's not that's not really pertinent information. That's something we don't really need to know. But the actual question here asks us to write this number in scientific notation. Okay. So we want to write this with scientific notation. So first thing you should do is write out the actual number just as it is there. So I'm going to drop off the dollar sign because we're only concerned with the number. At this point, we don't really need to know if it's dollars or whatever it represents. We're just looking at the number. So we have 3,400,000. Okay, and I write it, the number anyways, exactly as it shows up in the question. Okay, so now let's follow the steps. First thing we need to know is, in this number, where is the decimal place? Well, this is a whole number. It would take you a long time, but you could count to this number. But just as any whole number, the decimal place always shows up after the ones place. So we can rewrite this as 3,400,000,000.0. Okay, so 3,400,000,000,000.0. Okay, not to confuse anybody there, but once again, knowing where the decimal is important. So it's after the 0 that's in the ones place. Okay. Now what we do is we move the decimal place until it's until it's after the first non-zero number. So if you look at this number, the first non-zero number is going to be the 3. So we want to move the decimal to where it's going to be right after the 3. So we take it and we move it all the places. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's where we want to put our decimal place. Okay. And once again, if you wanted to just move it over and then count how many dips you have. So we have 1 dip, 2, 3, 4, 5, 6, 7, 8, 9 dips. Okay. So that means we move the decimal 9 places. But here's where the common sense, and here's where you got to really know what you're doing with scientific notation. So we're going to end up with the number 3.4. Now notice I leave it as 3.4. You don't need all these zeros at the end, but if you wanted to write them out, you could. But the whole point of scientific notation is so that you don't have to write all the zeros out, okay? But in this case, we're going to have the number 3.4 times, it's always the number 10 here, so times 10. And now we put the exponent on the 10. But in this case, we need to know, well, should that be a positive or a negative? In this case, it's going to be a 9. Once again, 1, 2, 3, 4, 5, 6, 7, 8, 9. We move the decimal 9 spaces. And here's where we have to have a little bit of common sense. We started off with a really big number, right? And we made this 3,400,000 into 3.4. So in order to make the 3.4 as big as the 3,400,000,000, okay, we would have to have an exponent of positive 9, okay? So it has to be a positive 9. And that is simply because, once again, if you're paying attention from the start, we started off with a really big number and we ended up with a small number, okay? So in this case, we want to take the 3.4 and make it bigger. That means we have to multiply it times 10 to a positive exponent, okay? But that's really it in terms of what this section is about in a way, is taking a number like this and writing it in scientific notation. Now, example 2, we'll see here in just a second. This was about writing large numbers. Well, example 2 is going to be about writing small numbers. So it's an example where you would use a negative exponent. But that's the thing. One way you can think about it is if you go from a bigger number to a smaller number, you need a positive exponent on your times or on your 10 here to make this 3.4 as big as the 3,400,000,000. Okay. Now let's go ahead and look at example 2. Which let me go back actually, because I do want to make a little note there for you. So in this case, if you start with a bigger number, use a positive exponent. And once again, that's just because we want to make this 3.4 into the 3,400,000,000. Well, you're going to have to multiply that times 10 to a positive exponent. Okay. On the flip side of that, if we look at example 2, it's actually the opposite here. We want to write a small number in scientific notation. So this one's about writing small numbers, which I guess let's be consistent here. Small numbers in scientific notation. Okay. And once again, they give you some context here about where they get this number. Okay. In general, though, you just need to be able to say, all right, I've got this small number. How am I going to write this as a number in scientific notation? So they give you some backstory here. So it says the rotation of the Earth is slowing. So it means eventually the Earth's going to stop turning. Okay, so it's slowing down the Earth's rotation. So one way to think about that is if the Earth's rotation is slowing, that means the days are going to get longer. Okay, and that's what they tell you in the next little piece of information here. So it says every year the length of a day increases by an average of 0.00000178 second. Okay, so every day, every year, the length of the day increases by an average of 0.00000178 second. Okay, but once again, that's all extra information here. What we really need to focus on is this number, okay? Because the next thing they're going to ask us is to write this number using scientific notation. Okay, so same instructions as last example, except for in this case, we got a really small number, but the process is still the same. First things first, I would write the number exactly as it shows in the example or the question that you're doing here, okay? Once again, we need to know where the decimal place is, so I always like to put the 0 in front, but the decimal place is after the first 0 that's in the ones place here. So once again, the decimal always goes after the ones place. Now, we need to go through and we need to move it. Well, we need to find the first non-zero number. Well, this is a 0. This is a 0, 0, 0, 0. Well, the first non-zero number in this case is a 1. Okay, so we need to take our decimal place and move it over to where it's beside or after the 1. So in this case, we need to move it 1, 2, 3, 4, 5 places. Okay. So what we're going to end up with here is, since we move the decimal over here to the right or after the 1, we're going to end up with the number 1.78. And this is still going to be times 10. So that's always stays the same with scientific notation. It's always times 10. And then the exponent on the 10, well, we counted over 5 spaces. Okay. Once again, 1, 2, 3, 4, 5. All right. And a lot of people are going to be tempted. Well, we moved it to the right 5 spaces, so the exponent here should be a positive 5. Well, this is once again where you need to really think about it. We're going from a really small number to the number 1.78. So in this case, we want to take this 1.78 when we multiply it times 10 to the whatever exponent. We want to make this number smaller. Okay. So in this case, we're starting off with a small number. Okay. That means our exponent actually has to be negative, a negative 5. Okay. So negative exponent. And just like the last example, let me give you a little hint here. So let me get the wording right, just right here. If you start with a bigger number, use a positive exponent. So if you start with a smaller number, you need to use a negative exponent. And once again, once you practice with some of these, you'll get better with it. It's like I said, it's kind of like a common sense type thing. We want to take this number 1.78, and in this case, if we want to write it as an actual number, we're actually going to want to make it smaller, so we need a negative exponent. Just like in this example, we wanted to take this 3.4 and make it bigger, okay, because we want to write it as a number in standard form. We would have to make it bigger, so we need a positive exponent. Okay. And that's pretty much it. Now, we'll go over example 3 here. Example 3, it kind of has the same kind of feel as what we just did, except for you got to do one extra thing, okay? So let's look at example 3, and we'll wrap this section up. So example number 3. In this case, this is about using scientific notation. Now, I do have to say, this type of question, you'll see, is in fact going to be a word problem, okay? So once again, this is one where you're going to have to really read the question, understand what it's saying, and understand how and what they're asking for as the answer. So got this big, long piece of information here. So a film had a budget of $128 million. Okay. Which that's a lot of money, but just in context, that's pretty average, especially for movies that have a lot of special effects like the Avengers movies and things like that. It's nothing for them to have probably even more than that as a budget, because they have to pay so many people to do so many different things. Okay. But they tell you here a film has that budget. And they also tell you during the first week of its release in or release to or release in theaters, it earns $59,400,000. So the actual question here is asking, how much more money does it need to earn to make back its budget? Ooh. Okay, and this is actually a multiple choice question here, so they give you 4 different answers here. So they give you A, 6.86 times 10 to the negative 8, B, 6.86 times 10 to the negative 7, C, 6.86 times 10 to the 7, or D, 6.86 times 10 to the 8. Now, when you're looking at these answers, if you got a multiple choice question like this, we can actually throw 2 of these answers out right off the bat, okay? Because once again, if we know the difference between a positive and negative exponent and how it affects the numbers we're talking about up here are giant numbers, big numbers, okay? 128 million, 59,400,000, okay? So we can actually go ahead and say that it's not going to be A or B because those are going to be talking about very, very small numbers, okay, because of the negative exponents. So in this case, the answer is either going to be C or D, but let's go ahead and go through the process here on how we would figure this out. We know if the movie had a budget of $128 million, what we could do is, well, that's how much the movie needs to make all its money back. So they spent $128 million to make this movie. That means they need to make $128 million before, they even begin to, and it's a term that they use in the business, is break even. So that means when they can actually start making money on the movie. Well, so if they start off with that and they made $59,400,000, well, we can take that and subtract those 2 numbers. So that way, that will tell us how much money they still need to make and how much they still need to make before their budget's going to be covered, okay? So once again, this is kind of like a common sense money type situation here. This is how much they used to make the movie. This is how much the movie made in the first week. So if we take the subtraction of those 2 numbers, that'll tell us how much more they need to make before the movie makes all of its money back, okay? So if we do that, we would have the number, okay? We would have the number 68,600,000. Okay? So after we do that, now comes the part that we're familiar with. All right, we have this giant big number here, okay? 68,600,000. And now we notice all the answers are in scientific notation. So now we need to take this number and write it into scientific notation. So same as like what we've done before, we have this number. We need to figure out where the decimal is. So if we need to put a 0.0 here, so we know it's right after this zero, the zero that's in the ones place. And now we take it and we're going to move the decimal place to the first number that's not a 0, which is the 6. So we're going to put it to the right side of that. So let's move it that many places. 1, 2, 3, 4, 5, 6, 7. Okay, so we're going to move it 7 places. And once again, if you want to just move it first and then count the number of dips, there's 1, 2, 3, 4, 5, 6, 7 dips that I made. Okay, So that means we're going to have the number 6.8, and then the 6. There's another 6 there, so the 6. And then, like I said, we don't technically need all the zeros at the end. That's the whole point of scientific notation, so we don't have to write all the zeros. So 6.86 times 10, and then here's where our common sense comes in. We're going from a big number here, 68,600,000, to the number 6.86. So what kind of exponent do we need on the 10? Well, we need a positive 7 as the exponent, because that's why we were able to rule these out, because we want this number to get bigger. Okay, so that's the number there, and that tells us the answer is actually C. Okay, now once again, this type of question, it relied on you being able to know about money and how money works, so some common sense operations with money here. So if they spent $128 million to make the movie made $59,400,000 its first week of release, then that means they still have $68,600,000 left that they need to make before they even can start making money on their movie. Okay, and once again, the whole crux of the question here was you had to subtract these two numbers, get that number, and then after you get that number, put it in scientific notation. So that's where the scientific notation comes in. Okay. And I've only put 2 of these on the practice and the homework. So if you're kind of confused about all the different things here in terms of why we needed to subtract these numbers or how I got this number right here, you could actually just put these numbers in the calculator and subtract if you needed to, because these are pretty big numbers. Okay, I don't expect everybody to just be able to do this in your head, but that's how I got this number. And then once I got that number, all I did was do the same thing we did in example 1, which was we took a big giant number and wrote it in scientific notation. Okay, so same exact thing here. But with that being said, we will skip example 4, kind of the same reasons we have before. Skip example 4, but do be on the lookout on the practice and the homework. There's going to be questions just like example 1, example 2, and example 3. So if you need to, come back to this video and look and see how I do each one of those examples, and that'll tell you how to do the questions that you have on the practice and the homework assignments. Okay? But if there are any questions, something you don't understand, please let me know. But other than that, thank you for watching.